So I'm going to be talking about building identity for an open perimeter. But before that, my name is Tejas Dharamshi. I am a senior security software engineer working on the Netflix's identity and access engineering team. So Netflix went global in 2016. We started streaming content in more than 190 countries. But when you think about when we started streaming content in more than 190 countries, what did this actually mean when we think from an enterprise security perspective? Not only were we going to stream content in more than 190 countries, our local presence in terms of our employee, our contractor population, was going to see an equal amount of expansion, which meant we would be having new office locations. And people, especially our employee and contractor population, either they'll be working from those office locations, or they might be working remotely, which meant they might be connecting through any public Wi-Fi. We started making more original content than ever before, both here in the US and all across the globe. And which meant the applications that were being built, which are specifically focused towards the production use cases, was going to expand, which meant people who are working on our productions, they would need access to these applications. And they are going to be on the go, which means they will be connecting through any public Wi-Fi. Our other facets of business, which includes our post-production lifecycle, our localization partners, which are all across the globe, our device, ISP, our media partners, every facet of business was going to see a dramatic shift in how we think about security. And to add to the mix, the kind of applications that were built or that were going to be built, they need to go through this cultural mind shift in terms of not just those applications, the scope no longer for employee and contractors, but now the scope has expanded, meaning every other facet, meaning all the B2B users are going to be accessing the same applications. And they have to be made available outside of the corporate network. So we clearly had to rethink in terms of how we think about perimeter-based trust and how do we detach ourselves. And there are a lot of reasons why we would actually want to do that. The cost and complexity that's involved in setting up and maintaining the infrastructure all across the globe is just going to be very expensive and not very efficient. And not to mention the risk that it exposes of having just a network-based perimeter. So we clearly had to shift our direction. And this is where we shifted towards more of a zero trust model. And any of you guys have seen last year's talk at Enigma around Lisa, which gives a great insight into Netflix's approach on how we think about zero trust. And a lot of other examples. Beyond Corp is a very good example on how you think and move away from a network-based perimeter. So what exactly is zero trust? The core idea behind that is access to any resource, internal resource or external resource. Access to those resources coming from a corporate network should not imply any trust. It should not give you any privileged access. You should think that an attacker is already present on many of those perimeters and has enough access and can assimilate just as you. You should start thinking about your corporate network as just as any other public Wi-Fi. And think coffee shop. So this is where this basically led to inception of our identity platform, which we term it as Meacham. The core idea behind the platform is federation, meaning what we want to do is we want applications to delegate the authentication and authorization process to us. And application developers just focus on building applications. And once we strongly authenticate and authorize a user, we will give applications a signed verifiable piece of information, which they can actually verify. This has a lot of advantages if you think about this particular model. From our team perspective, now we can start adopting standards. And standards are very crucial, specifically around SAML, OpenID Connect, and OAuth. We can use the same standards to gate our applications, and also we can use the same standards to gate the third-party SaaS applications as well. We can layer our security in terms of what we think is the right level of assurance we need from who the login user is. And we can provide the best in breed of end user experience as well. From a team that is building application, now they can just purely focus on that and leave the authentication and authorization process to us. They can get pluggable security so that there's zero room for any error, especially when you think about security. And they can do all of this via self-service. What about the end user itself? We can give them best of breed of experience via single sign-on. So a lot of advantages to start thinking in this direction. The core to the platform is the identity itself. What do we know about you, who the user is, and who is trying to gain access to our applications? And when identity is at such an epicenter of our platform, we don't want to be in a situation where we have silos, meaning identities scattered across our ecosystem and different identities used to access different applications. It exposes a huge risk to any organization. Different identities, as I mentioned, to access different applications, different security practices followed by these silos. And we cannot have a consistent authorization model as well. What about the end user? It produces the worst experience. Now, people have to think, what should I use to access which app? And we cannot have single sign-on again. So this is where we have streamlined in terms of how we get away from these silos and have a consistent view of a person or an identity. So from an employee and contractor perspective, we've streamlined where the identities reside. So we completely manage them inside Google's cloud identity. For all the other B2B use cases which I mentioned, which includes a pre-post production lifecycle, our studio partners, our content, our device, ISP and media partners, all of that other ecosystem, we have built our own IDP for that. And we manage all these identities inside that. But one aspect is how do we streamline where the identities reside? The other aspect is how do we make sure that identities come in and go out of our ecosystem when it's the right time? So every identity that we issue, they go through a strong provisioning and deprovisioning process. And this is very crucial, not just for our organization, for any organization, when we think about if you want to move trust towards identity. So the core building blocks of provisioning and deprovisioning processes, we'll tap into some external events. And when we receive those event streams, we will process those event streams and provision the right identity that is needed. And once we are done processing and provisioning those identities or deprovisioning them, we'll emit out notifications so that other application services in our ecosystem, they can actually tap into the same events to carry out post-processing. But what type of events? So we tap into a whole bunch of HR event sources, workdays for employee and contractors, ESN for all of our production use cases. So we tap into those HR event sources. What about all other B2B use cases, which might also emit other types of events that we might want to tap into? For example, production-related events. What's the start and end date of a production? When is the right time to get people in and get out of our ecosystem? Other B2B use cases like vendor contracts, right? Can we use that as an event? What about the activity of the user itself? Just because we provision identities, that doesn't mean that we let them be in our ecosystem forever. If there has been no activity, it might be better to move them and get them out of our ecosystem in a staggered approach. So provisioning, deprovisioning, and making sure identity silos are not there is one of the very core fundamental building blocks of our platform. So now, how do we start establishing stronger authentication and detecting detecting who the user is, and how can we start establishing some assurance towards that? So multi-factor auth is at the core of the platform. So users go through the first factor using their credentials, and they go through the regular step-up process as well. And as we have a wide variety and diverse population, it is important to support a range of options based on various use cases. So we support push notifications, we support TOTP, security keys, any possible method that's available out there. But if you think about multi-factor authentication, should be multi-factor auth every user every single time that they try to go and access applications? It would create such a bad experience. Is the risk level associated with a user trying to access a lunch menu application, is it the same compared to a user trying to access application that's exposing data? What about some applications that are financial applications? Each one has a different level of risk associated with it. So this is where we start thinking in terms of an attacker, like what an attacker might be doing when they're trying to compromise somebody's credentials and trying to get access to our ecosystem. And we have taken this model and built an adaptive authentication system, which is based on identifying what is the riskiness associated with an authentication request. And there are various core building blocks that go as far as discovering that. The first core ingredient is what is the likelihood of a user trying to access an application? We have a lot of interesting data elements available about the user. We have users' previous authentication history in terms of what applications that they have gone through. We have other attributes about the user in terms of what organization the user is, what team, what business unit, and what production the user is part of. We have various different combinations of data that's available. And we can come up with a nice heuristic in terms of is Tejas likely to go and visit some engineering application versus a studio app versus a financial application. So that's one of the core fundamental ingredient of our adaptive authentication. What about the previous authentication activity itself? So if this is an attacker trying to compromise my account and trying to gain access to Netflix resources, in those cases, the attacker might be gated by a lot of step-ups all through the way. And in such cases, those requests will either be failed or they might have been left abandoned. So can we use that and feed into our adaptive authentication to bump up our risk score to a more moderate level, right? Which means like we need to do more step-up for this user. We might want to time box certain applications and make sure that users are going through regular step-ups. For example, if I'm trying to access AWS console, I might want to just time box that every 6 hours. I have to go through a regular verification as well, right? So time boxing application is another key aspect to our adaptive authentication. What about every application that is built in our ecosystem? Each app has a different level of risk, depending upon what kind of data that they expose, depending upon what is the availability of that application, meaning it's internal, external, and other interesting aspects about the data in terms of if there have been previous vulnerabilities discovered for those applications. Various data points that can actually be fed in terms of a risk level associated with an app itself. If a user has been accessing our ecosystem from a known device, then we might want to actually reduce in terms of the riskiness associated with the authentication request itself. What about the location from where the user is trying to access our application, right? So like if the request is coming from certain risky locations, which we deem risky, in that case, we might want to just outright deny the authentication request. In other cases, we might want to step up, but in such case, we might want to just deny. So a lot of interesting ingredients. These are some of them, apart from a bunch of other things. But what are the interesting ingredients that go into our adaptive authentication? So adaptive authentication is one of the core ingredients to our layered security. And all of this, what I just mentioned, happens real-time, runtime, as and when we see new requests coming in. What about the health of the device from where you're trying to access application? And what do we know about that? Because that is another interesting signal that we can actually feed into our adaptive authentication. So there are a ton of endpoint security software which work really great. And especially if you're in a completely managed environment, then those would work really great in terms of you defining policies and based on that, making sure the devices are in a particular healthy state. But with Netflix, things are very different. Especially where our B2B business model is going and our culture, how that plays as well, meaning people have complete freedom to walk into any store, buy a device and use it for work. So thinking of that specific culture and where the business is going, what can we do in terms of still having a stronger assurance in terms of the health of your device itself? So this is where we built a native application known as Stethoscope, which basically, based on the policies that we set, it recommends people in terms of what are the best practices in terms of the health of your device itself. So me as a user get educated, I can self-correct it, and I can get my device in a healthy state. But this information goes that far if you cannot put it to use, especially to drive our adaptive authentication. So during our auth process, we do like queries to the app itself. And once we query once we query device-related information, and if it detects certain things which are not based on the policies that we have set, in that case, we recommend those corrections to the end user. Now, people can self-correct it and take appropriate actions. And it's kind of a win-win situation now. We were able to get devices in a state, in a recommended state, and users got educated as well, right? So it is an interesting approach in terms of going away from a managed device model and how you think about BYOD specifically. So device health is yet another core ingredient of our adaptive authentication, and is also another core ingredient in terms of our layered security as well. So now we strongly authenticated our users based on various different factors. Now, how do actually applications integrate with our platform? So one common approach that you see in the industry is having a mega proxy, where every possible authentication request goes to the mega proxy, and that's where you apply all the things that I just mentioned. But with Netflix, we want to keep few things away. One of them is the cost and investment of setting up and maintaining this infrastructure. We don't want to go in that direction. And we don't want to introduce single point of failures. So this is where we want to actually push the integration right to the application layer itself. And when we want to go in that direction, we don't want to be in a business where we have centralized DevOps team, which is actually managing these integrations and becoming another choke point in our ecosystem. So self-service is very crucial in terms of how we want to empower our engineers to be able to drive these integrations themselves, but in a way that it's simple, intuitive, and people don't have to think about the complexities associated with the things that I just mentioned. So this is where we have built an OpenID Connect compliant self-service, which basically guides engineers through single click in terms of what are the best practices you get by default. And you can go through like various advanced configuration to actually update things accordingly. So this is great, and it helps reduce the support burden in terms of new apps coming out, new integrations needed. It just makes it a distributed problem now. But UI goes as far as people can actually use. But now we want to drive these integrations far-fetched into our ecosystem. So API first is what is something that will get us there. And at Netflix, everything is API first. So this is a classic model to use. But when you think about the culture again, in terms of freedom and responsibility, developers are free to use any language, any tool to build applications. So we are in a polyglot environment. So how do we go about making sure these integrations are done in a right way? One approach would be to recommend a lot of open source libraries and leave the burden to the developers in terms of how they would actually go about configuring those integrations. But this has a problem in terms of new languages coming out, new libraries needed, or existing libraries having like vulnerabilities. Like how much catch-up game are we going to play? So one thing you hear common in Netflix is the notion of paved road. When you're on the road, you get best of the things in terms of best tools, best support, best documentation, and best of everything. When you're off, then you're on your own. So how can we use that to power our integrations? So one approach that we take is, especially if you're on the Java track, you get Apache by default, right? So how can we use that? We use the mod.auth OpenIDC open source library to wire up these integrations. That works for a large chunk of applications. But can we push the authentication even upstream, right? So Netflix is largely on AWS. So what can we use when we think about AWS in general? So over the year and a half, we worked very closely with Amazon's ALB team. And now ALB support authentication directly from the load balance layer itself. So it does support Amazon's Cognito. But the cool thing about this is you actually wire up your own IDP. And this is where we can actually wire up our own IDP as well. And as mentioned, API is crucial for us to get our integrations like far-fetched into our ecosystem. So if any of you are using our CI/CD platform, which is Spinnaker, so we have integrations configured from there as well. and which basically talks to Amazon to set up the load balancers. So leave all the complexities in terms of what you can get from AWS, and rather just provide single-click configuration setup. Similarly, Spring Boot is another classic example. When you just do do project generators, like you can actually set up those integrations by default. So we're strongly authenticated end users. We have an interesting way of setting up integrations, which requires zero configuration from any developer. But does that mean every person who goes to access our application gets access to our applications because they're strongly authenticated? Might not be a good idea. So in that case, from the same self-service, what we do is we basically provide a base set of access control rules that you can actually apply in terms of which user base you want to apply, which group of population you want to actually allow access to your application. And so use the same self-service to actually wire up those integrations. But if this does not work for a certain portion of our developers, then what we do is we package up information in terms of what you think you need from attributes that we would like to give you. And we package these up and give those as access tokens to the application. So they can verify that and apply other fine-grained authorization controls in there. So access control or authorization is another core ingredient. Another interesting aspect about access control is we provide the base level access control, and people can use or developers can use access tokens to actually get information and apply authorization rule. But the same piece of information can be used in other authorization systems that we are building within Netflix as well, right? So same piece of data, but in different formats can be used to apply access control. So we have a large population of applications to gate access to, and we want to make sure that identity is at the very epicenter to everything we think about Netflix. Followed by having a stronger adaptive authentication and figuring out whether it's actually really needed for us to actually even do any step up to our end users. And when it's about to doing step up, then a range of options is important because we have users not just here in the US, all across the globe, and various different from various different diversities as well. And authorization is another crucial aspect in terms of when you think about layering our identity. Authorization is another crucial part to it. And all of this by adopting standards. Standards is super crucial because now we want to use the same thing to protect our own application as well as third-party SaaS apps. And everything we are self-service because we don't want to be in the business of how different parts of our business are moving. We want rather to empower our engineers to basically manage those integrations. And we want to spread the integrations as far-fetched into our ecosystem so that there's zero room in terms of developers making mistakes. And so we want to drive these integrations far-fetched into our ecosystem. So these are the core ingredients which we think are important for us moving towards an identity-based parameter and detaching trust in the network-based parameter as well. So I'm happy to take any questions now. Yeah. So in terms of, sorry. So the question is, do we have to write different states in terms of what the endpoint was and how do we basically feed that into our adaptive authentication? So we don't have to maintain different states associated with a device, and we don't maintain different states associated with a device. It's at the point in time when we really think a device trust is actually need to be figured out, is when a live query is done to the endpoint. And if the query gives us the right information, that's what is actually used. So no previous states of the device is truly actually needed to make decisions.
Any more questions?
Right there, I think. Sorry, I can't hear the question.
Thanks for your presentation. Can you talk a little bit more about how you implemented device health? And was that a sliding scale across your ecosystem, or was that a hard brute force limit? If people didn't meet the minimum criteria, they couldn't access any of your apps?
So it is in the state in which we are right now. So there is no hard force like blocking rule that we have applied, especially with respect to device trust itself. So it is basically point in time, as in when the device health data is needed, and if we have not collected like a previous state of the device over an X period of time, that's when we basically re-prompt the user to query the health of the device itself. So it's based on the time period in which we had last seen the state of the device and whether we have done actually a step up. If we do step up, then doing a device health check simultaneously might not be a good experience as well. So either of those two and the time is the factor. Yeah.
In terms of GDPR, do you request from the customer that you're requesting this information? Do you get their approval first?
So that's an interesting question. So from a GDPR perspective, do we request consent from the end user, especially when we are talking about device-related information, and what do we extract from the device itself? So the device runs in a non-admin, the app runs in a non-admin mode, meaning anything that is available or that can be read in a non-admin kind of setup, that's what we basically try to query. In terms of consent, no, we don't ask for user consent, because right now the application that I'm talking about, the stethoscope app, is purely for internal employees, and it has been deployed in that specific scope. But yes, it'll become an interesting aspect as we start deploying it to our B2B use cases all across the globe, and some of those things might be to be looked into. Yeah. Any other questions?
I think one more question. Anyone?
Right there. So the question is, have we looked into some other stronger like endpoint protection software, and before we started building our own application? So we wanted to move away from a managed device model, as I indicated, because a large population of our user base is now moving away from just being purely employees, but rather an external population. So we really want to shift away from a managed device model. So previously we were using Jamf and Landis for setting up those policies, but we have detached ourselves from that particular model. Yeah. Any other question?
Any more questions? We're still good on time. No?
All right.
Thank you.
Thank you.